Good evening, everyone. Welcome to the very first edition of the DevOps Meetup organized by the DevOps Sri Lanka community. Let me introduce you all to the very first guest for today, Mr. Sanjeewa Alwis, Director and Cloud Operations and Site Reliability Engineering, Pearson, Lanka. Sanjeewa is a recognized leader in the IT infrastructure management and IT operations and is also a DevOps practitioner with over 15 years of experience. In his job role, he functions as the Director of Cloud Operations and Site Reliability Engineering at Pearson, where his main focus has been in managing various IT engineering teams in dynamic, mission-critical and global environments. He has proven a track record of providing continuous strategic leadership with concepts such as PaaS and DevOps to help consumers to maximize investments in IT. And we warmly welcome you to the very first DevOps Meetup. Well, without taking much time, let me move on to the first item in the agenda, which is the keynote speech under the theme of holistic approach to DevOps. Let me invite Mr. Sanjeewa Alwis, who is the Director for Cloud Operations and Site Reliability Engineering.
Hi everyone. Hiroshi kind of made me nervous with that introduction. So, okay, let's start. Thank you for being here today, and I think it will be a splendid evening for all of us, and we will have, I think, a good time here. Probably my session will be covering the high-level concepts, thoughts, and ideas about DevOps, how we, look at the DevOps from a holistic point of view, and then later we will be having another session. So mainly, I just wanted to tell you that the audience, some of you might need to get in deep dive into the technical details, and some you want to look at the high level process point of view. So I will try to keep this session in between these two dimensions. But any point, if you want to ask me any questions, if you want to just interrupt the session, please do that. Then we can have a detailed discussion of what you have in your mind. So that will be I think a good approach to have. Yes. So let me. I think. Let me try to fix this first. Sorry about that, it's my mistake. So I was introduced, so I don't need to introduce again myself. I'm Sanjeewa Alwis. I'm here because I like technology, I love DevOps technologies, and I love cloud technologies. So I have been helping to many organizations in Sri Lanka to transform into the DevOps world, and also many individuals to transform their career to the DevOps world, and to build the skills that is required to become a true DevOps engineer. So if you have any issues, anything, any help you need, just hit me up in LinkedIn. I can help you out. If I'm not technical enough to answer your questions, definitely I can relay you to someone whom I know to get your things sorted out. So this is about just an introduction myself. So you can find me in LinkedIn. Right. So let's get into the meat of the presentation. But before that, I wanted to highlight few things. So I want to engage this audience and then have a meaningful conversation during my session. I'm not expecting to, deliver this as a speech in one way. So if you, again, I want to highlight, if you have any issues, any questions, please interrupt my session and then ask the question, and then we can, move forward from there onwards. And also, I'm not very good at, making jokes, but I want to engage you somehow into the session so that, we will be having a meaningful discussion. So what is DevOps? I don't really like to have a definition for DevOps because, it has been evolving for many years and still evolving. But ultimately, what I can tell you is DevOps is a culture, way of working, and new method of thinking. So what does DevOps solve? What is the problem that DevOps is solving? If you think about the way that business works, for technical people, you might not really want to understand this. However the business works, we don't care. But I just wanted to tell you how business works and why DevOps is needed to fix some of the problems that we have in the industry. So let's say if you have a product and if you want to, if you have an idea and you want to convert that into a product, then the traditional way of doing this thing is we gather the requirements, business requirements for the product, and then we build the products for years, and then we release it to the customers, and by that time maybe customers' requirement have been changed, right? Customer might need a new thing, but that was how we did software development and operations over the years. We gather all the requirements and we build a perfect product, and then we release the 1.0. By the time when 1.0 goes to the production, the customer requirements might have changed. But whereas the products like Facebook, Airbnb, Uber, how they make the changes, they continuously evolve their product. If you have used the Facebook for last 5-10 years, you wouldn't notice a single day you wouldn't notice that a single day where you find a drastic change in the platform, right? You never come across drastic changes in the platform. But over the time, if you think about how you used the Facebook 10 years ago and now how you use it, the technology and the features have evolved a lot over the years. Facebook does not release 1.0 or 1.2 or 2.0, right? Even though they have their internal versioning, but how they evolve the product. So why they want to evolve the product is to quickly adapt to the customer needs. When there is a quick market boost on something, and if you want to make a change to your product, make a change of your product to it and accommodate that, you'll have to quickly accommodate. You'll have to quickly release. You have to make the changes rapidly to the product. So that is what was missing in the industry. Even in the current industry, what we do is we gather so much requirements over the years, and then over the months we gather all of them and try to release a product. Try to release a product that caters the requirement. But by the time it is too late. Some competitor, startup came up and then has kind of jumbled everything and took over the market. So this is the fundamental problem which DevOps is solving. And then there are so many buzzwords around DevOps. I just use this words puzzle. When it comes to DevOps, there are many areas like many things to talk about: cloud, continuous integration, continuous deployment, and then the tools like Terraform, Jenkins, Jira. Different tools are available, right, in this DevOps domain. So why I wanted to bring this here is to make you aware that we are exposing to a whole new world of technology with the DevOps. Now this is something where we are going to challenge the existing ways of working, right? Now many organizations in Sri Lanka, what we do, somehow our client wants to clients are asking us, is there any DevOps in your practices, in your products? Do you have DevOps? That's what they're asking. And then to have some little DevOps flavor into your product, you just set up a DevOps team. And then this DevOps team is pretty much doing the release engineering. I want to challenge that. I want to challenge you. I want to challenge the organizations of that traditional thinking and the weird way of using DevOps term in succeeding or getting the client, because that will be if you can win the client for that moment, just showcasing a DevOps team that you have, DevOps team or something like that. But ultimately, you won't solve the problem of continuously releasing. So I want to ask you one question from the audience. How many of your organizations practices DevOps? Can you please raise the hand? Because I want to kind of engage you guys. Can you please raise the hand? How many guys? How many industry using DevOps? Yeah, that's quite a bit of number. I'm not asking any questions, so don't worry. just wanted to understand the dimension of it. Okay, so how many of you do releases over the weekends or nights just to make sure that the production is not get disrupted? Yeah, so pretty much all of you. That means, including you, me, and everyone, we are not practicing DevOps. Score is 0. If we are releasing over the weekends, over the nights, that means we are not DevOps. We are not practicing DevOps. We might have a so-called title, DevOps, and I myself is a culprit of this, right? So I'm not trying to play the blame game here. We, as an organization, we all are facing this in Sri Lankan industry. So if you want to become true DevOps, that means like the way that Amazon is doing. They have the world record of releasing. Like in 4 years back, they released about 4,000 releases per day. Sorry, per hour. And they do not change, they do not take downtime, right? Have you ever seen AWS taking a downtime? Maybe once or twice, right? But so many changes they are doing to their platform. And if you take Oracle Cloud, Oracle, the way that Oracle operates, one of our sponsors this event. Do you think that they are Oracle Cloud and these cloud providers, these bigger giants like Oracle in the industry, are they making any like 2-3 day downtimes like we do? Because for Oracle, it's like every day is a working day for them, right? So if we ask for a downtime for their client, they won't be having any clients. But they make changes. That means they have set up a way of working. So these are some stats. So DevOps is emerging, and about $178 billion in the world is the DevOps market. And DevOps related technologies possess this much, and maybe if you add some newer technology that comes with Oracle, that might be more. I took this from Harvard Business Reviews for 2018. And then 50% of global enterprises are trying to adopt DevOps. And still, 5 in 10 businesses do not understand what DevOps means to them. So that's why we are trying to, in this first session of our DevOps meetup, we are trying to fix this core fundamental problem. So this is something where I wanted to talk about a bit on some of the concepts. So before that, I want to tell you one concept around this DevOps. The fundamental expectation of DevOps is to enable the developer to make release faster. So we are expecting developer to do fast releases, and why we wanted to do is, as I said previously, in a ever-changing business environment, we need to quickly deliver what customer is wanting. So in traditional agile way of working, in agile practices, they're supposed to release something at the end of the sprint. Sprint can be 2 weeks, one week, or 3 weeks, but at the end of the sprint, they should be having a releasable code in front of them, right? So that in that case, they have to make the release to the production. So how they should be doing that, and what are the blockers that they had? The biggest blockers that they had was the operational world. The IT operations world is not ready to cater that requirement. IT operations is not ready to continuously release. why IT operations require about 2-3 months to set up a new server and to host an application there, host the OS version, create the virtualization, and then host the OS. They'll take ages. And then once they have the code in front of them, they don't know anything about the code. They just dump the code into the production environment and watch it fails. Right? That is what is happening within the traditional way of working. So, how many of you in this group, can you tell me, are from IT operations? Yeah. There are quite a few, very little number of IT operations, but IT operation, if you are an IT operations person, if you're coming from that background, you will understand the pain of managing someone else's code, which you do not have any control over it. But now, when we have a requirement of continuously releasing, you cannot take ages to set up your environments. You cannot take months to configure the virtualization environment and spin up your servers. The environment, the servers, everything should be readily available, right, with a click of the button. That is where these concepts coming in. So with DevOps, one of the concepts that is evolving in the industry is infrastructure as a service. Organizations like Oracle or Amazon, Azure, these organizations provide the infrastructure as a service. In previous days, if you want to buy a server, you would have wait like 3 months to get it set up in your data center. You have to procure that, go whole lot of processes to make sure that ultimately your server in your data center. But now, with the cloud technologies, it's just logging to the console and spinning up a server, or talking to the API and spinning up the server. So the infrastructure as a service is a key enabler of DevOps. If you don't have infrastructure as a service, you really cannot do DevOps. Whether it can be private cloud or public cloud. This is kind of a very adamant statement, but I want to make that statement where if your infrastructure is not fragile, infrastructure is not changing, if your infrastructure is not customizable, then it's tough to achieve DevOps. And then the other concept is platform as a service, PaaS. Now these traditional public cloud providers have created the PaaS environments on top of them. For example, AWS, Oracle, they have their own platform as a service tools. For example, I'm actually, pardon me, I'm not an Oracle expert, so but I'll get an example from AWS, where if you want to deploy a code, you can use services like code deploy in AWS. So there are services that enables us to do the deployments. So whether it is in-house private cloud or whether it is public cloud, we will have to use these platform as service tools to enable DevOps. And then finally, these things enable SaaS platforms, right? This infrastructure as a service, platform as a service, enables software as a service. Now most of our products, SAP products, everything runs on cloud. If you take Oracle or many vendors in the world, that they provide it as a service. They provide the software as a service. So it's matter of us. It's matter of us to integrate all of these things into the core DevOps concepts that we are building. So these are the key enablers, and also there is something called business as a service, which will also enable it, but I'm not taking a lot of time in explaining that. So I think DevOps is needed to enable these things, and vice versa. Infrastructure as a service, platform as a service, and software as a service is needed to enable DevOps. So these are the 5, I wouldn't say pillars, but I would say some high components of components that you will be needing when it comes to DevOps. So all of these things are needed to enable developers. So this enabling developers is a kind of a tricky word, right? Enabling developers is sometimes a scary thing for operations engineers. I'll tell you a small story. So like in 10 years ago, I had one of my friend. He one day came home after a party, like, enjoyed with their friends and then had a good time, and then he came about like 11:30 or 12 in the night, and then he didn't want to wake his father, so he was like looking away to get into the room, and then somehow he found out that the window is open. He has jumped from the window, and then he has jumped from the window. When he get into the house, he has seen his father is standing up in front of him. Father is asking him, "Why are you jumping from the window? The door is open." Right? So, it is something, enabling developers is something like that. You can, in a way, developers can find a way to get into the production environment if you are not controlling it well. Right? They can just get into the production environment and make the change in the code and then make it look like it works. That is not DevOps. When I'm saying the enabling DevOps, enabling developers, meaning I'm saying that we need to enable developers to make changes so fast in a controlled way. That is where we can use these things. So first of all, how do we plan releases? So we have to plan our releases. So it can be agile way, or it can be some software development methodology you have to have. But the release planning is important, and release planning should be done in a way small, frequent releases. That is the concept of DevOps. If you are waiting like 6 months to make a huge chunk of data, if you want to push it to the production environment, that is not DevOps. If you are doing DevOps, that means continuously releasing, changing small components. So that's one thing. And then continuous integration. So I have another question. Is there anyone in this audience who practices continuous integration? Can you please raise your hand? Good. There are about like 10, I can see 10 responses, 10 to 12 responses. Thank you very much. On continuous integration. So, can you raise anyone who is fixing your code, who is fixing your build if it breaks, if your build breaks within the continuous integration process, if it breaks, which company or which team that you are part of are you fixing that build within 2 hours? That is one person. I think to me, he's the only one in this audience who truly practiced continuous integration. Continuous integration means you have to continuously push the code to the code repository, and then and have the build, and then once the build is broken, you have to immediately fix the build, because the next person in line will make the merge into the production environment, make the merge into the software code. So when you have thousands of developers working for the same code base, like in Google, right? There are about 40,000 people working from about 40 to 50 offices all over the world to this Google code base. So they are making continuous changes, and that mechanism is very well set, where when you make a pull request first, and when you make your changes to the code, and then you run within your laptop or within your machine, you run your tests and you make sure that build is not failing, and then you merge the code to the software repository, and then in the software repository you run the build and the tests. In that process, if the build is breaking, then you have to immediately revoke it. Immediately you have to fix it, and you have to have the clean code in the software repository. So that is one of the principles where we should practice if you are using DevOps. So continuous integration. Each team's work is continuously integrated with that of the development and IT operations. So that is something the continuous integration is talks about. And then the next one, the continuous delivery. Continuous delivery is how do we make continuously releases to our environments. Once the build is done, once the build is ready and the unit tests are done, your next job is to deploy into an environment. Based on your company need, based on your team's need, you might have different environments. You might have the integration environment first, you might have QA environment, non-functional testing environment, performance testing environment, staging environment, production environment, whatever the environment it is, you will have to have this deployment automated seamlessly to the different environments. So that is one of the key elements of DevOps. With that couples with continuous testing. So you need to have continuous test. So this I'm talking about the core meat of the DevOps here. So as I said before, culture and many other things are there in DevOps, right? But the meat of the DevOps is continuous delivery of software, the continuous delivery pipeline. That is the meat. That is where we need to focus on. So I'm taking a quick break here just to ask whether I'm making any sense, because it seems to be like every time when I'm presenting in Sri Lanka in a conference, I feel like I'm not connecting. But at the end of the presentation, when everyone starts speaking to me personally, then I feel that people have connected, but they haven't shown it in the face. So everyone, I'm a little worried, like when everyone is looking at me weird. So I think I'm connecting, right? Thumbs up? Okay. If not, tell me. Then I can, somehow change something. As I said, I'm very bad at joking, so I don't know how to, make you laugh. But I want to somehow engage you. So, continuous testing. If you talk about testing, there are about 20 testing types, right? It can start from unit testing. When you are making the build, when you are running the build scripts, and when you are running it in your laptops, you will need to have unit test. Usually the developer creates the unit test. And then once the unit test passes, there are other set of tests which I will explain a little later. That can be acceptance testing, regression testing, or that can be non-functional requirement testing, or performance testing, or else we have in some cases accessibility testing, and then manual exploratory testing. There are different testing, but all this testing needs to be integrated into the code, integrated into the pipeline. And then when you make a check-in to the code, this thing has to automatically start up. This is where we are thinking of using DevOps pipelines. And then finally, when after all the testing is done, it goes to production, and it is continuous monitoring. You'll have to have continuous monitoring. That doesn't mean you will have to open your eyes in 24/7 basis, putting engineers to look at the monitors. That is not true monitoring. The true monitoring is where you wanted to have mechanism, SRE practices, site reliability engineering practices, like alerting. Proper alerting should be set up. That is a way of monitoring. So I think I explained this slide. These are the high-level concepts that I was talking about, and then again I'm taking you to the business benefits of the DevOps. When you do all of these things, you will be able to release fast, you will be able to increase the quality, scalability, resilience. You will be able to recover fast from an issue. You won't take like ages to fix a production issue. You will be resilient. And then time to market, you will be very fast to market. So these are the business benefits. I don't want to explain more on that one. So let me go into the basic deployment pipeline. So this is a pipeline snapshot of how I think about it. This can differ in many ways. So when you commit the code, you compile the code or you run the unit test, and then you run the static analysis like SonarQube to check the quality of the code. When you do, for every checking, if you have configured the SonarQube into the pipeline, then it will showcase the status of your code base. Whether you have code duplications, whether line coverage is good, whether you see major issues, blockers, that will be, SonarQube is a really good tool. And if you integrate check tools like check marks, then you can check all the vulnerabilities in the code from the security point of view. So once that is automatically done, once you have a better understanding of it, you will be able to build it. You will be able to build the code. And once you build the code, the next step is the automated acceptance testing, when you put it to the next environment. And then automated capacity testing, and then manual testing, and then releasing it. So all of these things can be vary based on the product needs. So I'm just at a general basic deployment pipeline that I was talking about. But based on your need of your application, let's say if accessibility testing is a really important thing, you will have to integrate accessibility testing here. And if something else you think is very important into your base nature of your product, you will have to have that. But the fundamental concepts of continuous build, continuous integration, continuous deployment, and continuous release, and continuous monitoring are core essential things. So this is again a little bit of a broader concept. So when you have this pipeline, now you need to integrate it with the infrastructure. So there are 4 different components that is required to run a code in a production environment successfully. One is the executable code, second one is the configuration, third one is the host environment, fourth one is the data. When you have all of these 4 elements automatically setting up, you can create a pipeline. For example, let's say when you in a cloud-enabled environment, in an infrastructure as a service environment, where when developer checks in the code to the production, checks in the code to the software repository, and then automatically builds, unit test runs, and once it is done, the automatically environment is provisioned for himself to deploy the code. That environment provisioning is automated. And once the environment provisioning is automated, you will need to provision the databases, and you will need to insert the metadata or testing data for that environment. That process is also automated. So there are many tools where we can achieve that. For example, this Terraform. Terraform is a really good tool in the cloud domain to provision infrastructure. You can write a script, and based on the configuration of the script, you can have many instances spin up in the cloud environment, and then the environment is ready for you to use for the use. So there are different tools and technologies which I am not going to deep dive into that a lot in this session, because we are time boxed, and also I'm supposed to have I'm supposed to invite for the next session as well. So this is the first session, but as I said previously, there will be in next sessions there will be, of course, very technical people involving in this DevOps group, and they are one of the industry leaders. This group who has organized this event. So kudos to them. Actually, they have the capability of getting into the details. In the first session, we don't want to do a demo on Terraform or any other technology, because that will be creating a more specific viewpoint for this session. So this is the pipeline. In many successful organizations, they just commit. Once the commit is done, everything flows in the pipeline and landed in production environment. And sometimes they use concepts like A/B deployment, blue-green deployments, to set up the identical production environment in a separatedly, and then once that environment is fully tested, you just switch over the DNS or something to make sure the load is switching to the new version of the code, new version of the infrastructure, and the previous one is discarded. So I will quickly wrap up. I think so these are the few best practices of DevOps which I want to highlight in my some sessions that I have done in here. I have highlighted this. The first one is develop on mainline. This is a very controversial statement. Many people have challenged me, and my response was, if Google can develop in mainline without having like 3-4 years old branches, feature branches, without having all of these things, if they can develop on the mainline, if they can make sure that it is not broken, with the 40,000 of software engineers, we should be able to do that. So developing mainline is a key thing. You have to develop, and you don't have to have so much of branches. That means you are getting back to your old software engineering practices, right? So if you have any questions on that one, let's discuss. Many conferences I'm getting challenged on this one. And the next one is only build your binaries once. For environment to environment, if you are changing your build, that is not going to work. If you have isolated all the configurations separately in a config files, the code is similar for any environment. If you have a proper configuration management mechanism, you don't have to have different builds for different environments. And then you are deploying the same way for each and every environment. If you are using Jenkins or Travis or whatever, Jenkins scripts to use a deployment in one environment, or GoCD in one environment, then you have to do it for the others as well, same. And then you have to smoke test your deployments always before handing over to the QA to make proper testing. And then this is deploying to a copy of production. That is when you get into the staging environment. You have to have a copy of production, identical environment, so that you won't get the problem of not working only in the production environment. So there are other things, I have explained those things, like you should, each change should propagate the pipeline instantly. When you commit the code change, it should go through the pipeline immediately. And if you can do it till the end of it, till the production environment, that is perfect. That is how many bigger, larger corporates are doing. They are not even waiting for 2 weeks sprint to release. Developer just commit it, and it goes through the pipeline to the production environment with all the testing integrated. And then any part of the pipeline fails, we immediately stop the line and then revert that back. So that is one principle. So there are some of other best practices. I think maybe you can have a high-level look at it. I'm not going to explain more of that. So one thing is your infrastructure should be specified through version control configuration. Tools like Terraform can enable this, where you can have a configure environment infrastructure as a code, so that you can provision the environment without any issue at any point. So that is the infrastructure level need. And then infrastructure should be autonomic. It should correct itself to the desired state automatically. These are the new ways of working in the cloud domain. The cloud actually helps us to achieve these things. Whether it can be private or public cloud, this helps us to achieve this. And then also you should always know the actual state of your infrastructure through the instrumentation and monitoring. That is, I have spoken about that before. So I have talked about many disruptive concepts. Some of you might consider it as disruptive, some might be considered as usual practices. But if you still have any questions, any thoughts, please let me know. I can answer that after the session or now. So from the presentation point of view, that's all I got. So thank you very much for attending, and if you have any questions, please hit me up in LinkedIn or anywhere. I'm there to create the awareness in the industry for the DevOps. Thank you very much.